Hello, thank you very much for joining today's webinar session. My name is Hitesh and I'll be your instructor for today's webinar session for Elasticsearch. So let's get started. So today in this session, we will be covering a little bit about Elasticsearch, what Elasticsearch is, and how do we run different queries in the Elasticsearch. So Elasticsearch, let me give you a little bit idea about what Elasticsearch is. It is basically a search engine which is based on Apache Lucene. So it helps in performing various kind of searching. It does the full text search or various kind of search mechanism it supports. So for now, this is the brief introduction about what Elasticsearch is. Let's quickly dive into the slides and I'll be going through the more detailed depth of what Elasticsearch is. So this will be the agenda for today's slide. So agenda includes what is Elasticsearch, why we need Elasticsearch, what are the advantages of adopting Elasticsearch, installation of Elasticsearch, various API convention which are used, various APIs, query DSL, mapping, analysis, and modules. So these will be the agenda for today. So let's understand what is Elasticsearch. So Elasticsearch is nothing but it's a real-time distributed and analytic engine. The best part about this product is it is an open source. I mean, it has been backed by an open source community. So anyone can download without paying any licensing cost. So it comes under the open source license and it is developed in the Java platform. And it is based on the Lucene engine on top of which we have RESTful interfaces. So whatever the search-based engine work behind the scenes, on top of which we have the RESTful APIs. So the APIs helps in fulfilling the request and responding to the request. So it supports full text search, completely document-based instead of tables and schemas. So there are some more search-based engines which are available in the market, but those are based on tables and schema-based. The best part about this product is this is all based on documents instead of schemas and tables. As soon as we'll be moving on in the depth, we'll be able to understand what is the benefit of having the document-based approach rather than a schema-based approach. And it is used for single-page application projects. So let's understand why Elasticsearch. So first of all, the benefit of having Elasticsearch is in terms of query. Well, in terms of query, it lets you perform and combine many different types of searches like structured as well as the unstructured searches. It also helps in working upon the data which is based on geography and which is also based on metrics. So irrespective of what type of data you have, whether it is structured, unstructured, geo-based, or it's a metric-based, Elasticsearch all supports that. And the best part about this is you can retrieve the result from the data which you import in any way you like. So it is all based on some structured query sets. So we write queries and we retrieve the results based on queries. So we can ask a query based on what you want from it. You can ask the query anyways you want. Second benefit of having Elasticsearch in place is it's let you understand billions of log lines easily. Because of the reason that it supports big volume of data, you can import your logs, and this search mechanism can help you to drill down the issue across millions of line of logs in a small period of time. It provides aggregation which helps you to zoom out to explore the trends and patterns in your data. So like suppose if I have a cloud environment of 500 nodes and I want to analyze the entire infrastructure in a short period of time, the best way to do it with the help of Elasticsearch, where I will be importing the logs into the Elasticsearch, and based on whatever response I'm getting in the Elasticsearch, I can very well get to the root cause of the issue in the shorter period of time. So that is one of the benefit with the help of Elasticsearch we get in analysis. So query as well as analysis both are taken care by Elasticsearch. One best example of Elasticsearch is here this person wants to search a file, all those files in which the place is mentioned as Dubai. So as you can see on the screen, there are multiple files, but it will search across all those files where the place is written as Dubai. It is also possible to aggregate the data by the number of days. Like suppose if in case I want to track down the files with the place Dubai created based on number of days, I can very well do that with the help of Elasticsearch. Also, since it supports the geography, so we can very well track the files, or I can very well track the files based on the geography, and I can present it in the form of dashboard that supports the geo tagging. So let's understand what are the advantages of Elasticsearch. First of all, it is scalable. By the term scalable means it can be scalable across multiple nodes. So eventually you can start with a single node or 2 or 3 nodes. And if in case your workload grows, then in that case you can scale across multiple nodes. So it is very easily scalable in terms of scalability. And in terms of the performance, it is really fast as compared to other search engines which are available. Another advantage, I should say, of Elasticsearch is it is multilingual. Another advantage of having Elasticsearch in place is whatever index which are created, or whatever you can say schemas are not generally used in Elasticsearch. Instead, all the data is stored in the form of documents. So whatever documents which are created, whatever information, it's a document oriented approach, and the data is presented in the form of a JSON format. So the benefit of having JSON format in place is it is a widely accepted web format, and we can integrate several solutions because it is able to provide you the output in terms of the JSON format. So you can use that output to present it or to integrate it with some other application in your environment. Another advantage is it supports auto completion and instant search. So there, whenever you start typing queries, you will see that it supports the auto completion. And last but not least, it is schema free because it follows the document oriented approach, where instead of schemas and tables, we have documents where the data is stored. Let's quickly go through the installation. So we will be going through the installation of Elasticsearch on a Windows platform, where you need to have the Java installed first of all. So once you install Java, the best place to check if everything is running fine or not is you have to execute a command in the command prompt, java-version. It will give you an output like this. This means that the Java is installed properly and the environment variables are properly set. One thing we have to keep in mind is Java version must be 7 or more. It should not be less than 7. So this is something which you have to keep in mind. Next thing is install the Elasticsearch zip file from the website. So once you will download the zip file from the website, you need to unzip the file and you just have to go to the bin folder. So there will be a folder called bin where you have to go, and then you have to run the elasticsearch.bat file. So this is nothing but a standard Windows batch file which contain the series of steps which it will be performing behind the scene. So it is just like a Windows script, which is when you double click it, it gets executed and it will be executing the task behind the scenes and eventually help in bringing up the Elasticsearch daemon on your machine. So you will be getting such kind of an output on your screen, and we have to wait for the Elasticsearch to start. So now the question which will be coming onto your mind is, how do I get to know whether the Elasticsearch has started or it is running or not? So the best place to check is open the browser. On the same machine, you can type as localhost :9200. So if it will give you an output like this, saying the tagline that you know for search, this means that Elasticsearch is installed and it is running properly. So this is how you can check whether Elasticsearch daemon is running or not. Next, well, for people who are installing the Elasticsearch on a Windows platform, that too locally, we can make use of the Sense plugin, which can help us to write queries and import the queries. There are two options to do that. So this is an approach which you have to follow when your Elasticsearch is local, installed on the machine. But if in case the Elasticsearch is remote, well, what I will be doing in my case is I have an Elasticsearch set up on my AWS cloud environment, and I will be accessing that Elasticsearch through the Kibana dashboard, and I will be accessing the same Sense tool through the Kibana, because Kibana latest version nowadays support the Sense as well. So either way you can do. Let's go to the basic concepts. So before we dive into Elasticsearch, we need to have a few more core concepts. We need to discuss a little bit more concept about the Elasticsearch. So basic concepts, near real time. This means that the Elasticsearch is so quick that as soon as you put the data into the Elasticsearch, it is all available to work upon. So Elasticsearch is near real-time search platform, that there is a slightly change in terms of time when you index a document until the time it becomes searchable. So as soon as you create an index or you upload a document, it becomes searchable. As I said, Elasticsearch is a distributed system, is a distributed environment, I should say. So with distributed environment, you can create these applications across multiple nodes in the form of a cluster. So cluster is nothing but it's a collection of one or more nodes that together holds the entire data. It provides the federated indexing and search capabilities across all nodes and is identified by a unique name. So by default, it will take the unique name as Elasticsearch, but if in case you want to rename the cluster name, you can do it by making certain changes in the configuration file. Node is nothing but it's a single server which is participating in the cluster. So it's a part of a cluster, it stores data and participates in the cluster indexing and search capabilities. Now let's understand what index is. Index is basically a collection of documents with a similar characteristic, and it is identified by a name. So whenever we want to work upon a collection of documents, we define the index on which we have to work. So you can consider it as an identification of certain type of document. So we categorize certain type of documents into a category, into a major category, we call it as index. So you can have multiple index across Elasticsearch. So suppose I have certain data related to movies. So I will create an index of movies and I will upload the data in the movies index, and whatever documents which will be created will be the part of that particular index. So this is how it goes. So an index is a collection of documents with similar characteristic and it is identified by name. Name is used to refer to index when performing indexing, search, update, delete. So whatever operation you want to perform, you have to define on which index you want to perform the operation. Let's understand what type is. Type is nothing but it's a local category partition of index whose semantics is complete. It is defined for documents that have set of common fields. So type is nothing but it's a category inside the index for partitioning of the index. So this is something which we will see. We can define one or more index type in one or more type in your index. Documents are nothing. These are the basic units of information, and it is expressed in the form of a JSON format, as I said. And since this is a JSON format, it is an internet friendly format. So you can very well fetch that information and you can use it in your tools or display it somewhere or the other. Let's talk about what shards are. So suppose if in case shards are nothing but Elasticsearch, it provides you the ability to subdivide an index into multiple pieces. Like suppose if I have created an index of a larger size as compared to my capacity which is there on that particular Elasticsearch node, what will actually happen? The Elasticsearch will subdivide that complete index into smaller parts which are called as shards. And these shards in itself, they are fully functional and independent indexes that can be hosted on any node within the cluster. So generally these nodes are distributed across, and we also configure the replica of these shards. So if in case someday a node fails, you will always have a persistent copy of data available in your environment. So Elasticsearch allow you to make one or more copies of the index shards, which are called replica shards or replica. So let's now find out the API convention in Elasticsearch. So these are the API convention. The Elasticsearch REST API, they accessed using the JSON over HTTP. So it's a RESTful API and it supports HTTP. And these are some of the conventions which are used throughout the REST APIs. We will be covering each one of these one by one. For now, let's name them as multiple indices, date, math, support in index name, common option, or URL based access control. So let's talk about multiple indices. Most APIs support execution across multiple indices. So different notations can be used to perform the operation on multiple indices. So suppose if in case you want to perform an operation across multiple indexes, then in that case what you can do is you can make use of certain expressions or certain what we can say operators like comma, wildcard notations, or some kind of string parameter. So these are the three things which is mentioned here, like comma separated notation. So if in case you want to separate the indices based on commas, you can very well do that. If in case you want to have a search, make the search, or you want to perform an operation using the wildcard notation, so we can very well do that. Or if in case you want to specify certain string parameter like ignore, allow no indexes, expand wildcards, these are some of the string parameters which we can use in our queries. So next is Elasticsearch lets you search indexes according to date and time. You need to specify the date and time in the specific format. So it's all the date and time. So whenever you want to search an index according to date and time, you have to specify in this format. These are some set of common operations for all the REST-based APIs. So some of the operations which we will be using it, like pretty results, human readable. So pretty results means it will give you an output in the form of a beautiful, not beautiful, but it will give you a more presentable output. Human readable output is another form of presentable output. Date math, response filters, flat settings, parameters, no values. So these are some of the options which we can use with the REST APIs. URL based access control. So user can also use a proxy with the URL based access control to secure the access of Elasticsearch indexes. So we can also make use of the proxies. So user has an option of specifying an index in the URL and on each individual request within the request body for some requests like multi-search, multi-get, or bulk. So this is done for secure access where we are keeping a proxy. We are using a proxy which is further having a URL based access, and we can make use of that proxy to query the Elasticsearch. So let's talk about the Elasticsearch APIs. These are the types of APIs which we have in Elasticsearch: the document API, the search API, the aggregation API, the cluster API, and last but not least, the index API. So let's quickly see what these are. So if you would ask me what these APIs are, I would like to give you a little bit of information about what these are. Let me go back to the slide. So if you would ask me what document APIs are, document APIs, these are those APIs that perform the operation on the document level. So if in case you want to perform some operation on the document level, you have to make use of the document APIs. You can very well do that with the help of document APIs. Likewise, the search API, it is used for search across indexes and all types. Likewise, aggregation is used for aggregation. If I talk about what index API do, it perform operation at the index level. So, and cluster API. So with the help of cluster API, you can perform the operation at the cluster level. So let's see what document APIs are. They are further categorized into two types: single API document and multiple API document. So these are the categories. So if I say here, index API, get API, update, and delete, these are the four APIs which come as a single document API. So if in case you want to perform an operation on a single document, you make use of these APIs for querying. For if in case you want to make use of querying across multiple documents, we make use of the multiple document API, like multi-get API, bulk API, if in case you want to bulk delete, if in case you want to do bulk update, if in case you want to do re-indexing. These are some of the queries which are implemented across bulk. So we will be doing this index API for creating a document. So if you would see here, this query, put means, see, these are some of the keywords which we use: get, put, post, delete in making the REST API calls. So likewise here, put is the method which is used. So slash playlist is the name of the index, and song is the name of the document, and likewise 6 is the ID. So if in case, let me show you these in my lab environment. So first of all, let me give you an idea about what this particular query is doing. This particular query is, so what we are doing is we are importing this document into the index. So the document will contain information like title, artist, album, and year. So I have this Kibana dashboard open. So this is in the dashboard, this is the dev tool which you can make use of for making the queries. So the same thing is what I have mentioned here. So what this command is doing, this is creating, so first of all, I may have this my playlist index already. So let me show you, get. So I have already created this index. So if in case I want to import the data into this index, like suppose I'm using 7 and title, let's keep the song as what song? My Holiday. I'm not sure if this is a song or not, but because right now nothing is coming into my mind. Artist, let it be me. Album, let it be Linkin Park. Year, let it be 2012, or let's keep it as 2011. So if you get this output as created true, this means that this particular document is created. So I'll go back to my slide now. So the same thing is done here. So with the help of put, I am creating the document. So if in case I want to read a document, I'll make use of the get method. So I'll show you this. So if you get this output, this means that this is used for reading the document which I created. So with the document ID as 6, this is the document which is created. If in case I want to read the document 7, so this is the ID 7. Make sense? So this is used for reading the document. Likewise, if in case you want to update a document, so for updating a document, the same thing, you use the put, and you should be sure about the index name as well as the document ID. So based on that, you can add the parameters. So if in case I will add another parameter here, location, Delhi, let's suppose. So it gives me the successful one. This means that the location is added. So if in case I want to get, so location is added here in the document. So this is how we perform these operations. Likewise, if in case you want to, you have a delete API, if in case you want to delete a document, you can do it similar way. So for deleting a document, all you need to do is to document ID, and you can very well delete it from here. So let me show you that as well. Delete LETE. Let's keep as document ID number 7. So if in case I want to delete it, successful one means this has been deleted. So these were the operations. Now let's go to the search API. So search API, using a search API, you can extend a search query and get back the search hits that matches the query. So search, as per the name says, it is used for getting the results from a set of data. So it can be a multi-index, it can be multi-type, or it can be based on URI search. So let's talk about what multi-index is. You can search a document presented in all the indexes or some specific index. Okay, so if in case you want to search across all the index, all the documents which are placed. You want to search for a particular document across all the indexes, you can do that with the help of this. You can search all the documents in the index across all type or some specific type. So this is what multi-type do. And there are some set of parameters which you can pass in your search operation in the URI. So like these are some of the parameters which you can pass, like queue, lenient, field, sort, timeout, terminate after, from, size, etc. So here is the example. So here what we are doing is we are fetching the information, we are reading a document. In fact, we are searching a document which contain year as 2011. So if you see the output here, it will show you year as 2011. So this is what search APIs do. All right, so let's move on to aggregations. So what are aggregations? These are nothing but if in case you want to collect the data and you want to work upon multiple data sets, we make use of the aggregation. So aggregation, it collects all the data which is selected by a search query. So this framework consists of many building blocks. So these building blocks are known as aggregators, which help in building the complex summaries of data. So if you would see below, this is the syntax of the aggregation. So these are the aggregator types: bucket, metric, matrix, and last but not least, the pipeline. So we'll see. So these are the different types of aggregation. I have some information regarding aggregation. Let me see if I can show you some aggregation stuff. So here, let me give you a background. We will be working on a different data set. For aggregation, I will be working on this bank data set. So it contains a lot of documents which I will be working on. So this is something which I've already uploaded. So let me show you some queries. So I have written some queries and we'll do quick in order to complete it in less time. So if you see this query, I will be running this query across multiple documents, across multiple indexes in fact, and whatever document matches the first name Rowena, it will give me the output. So if you would see here, there is an index called bank with the ID as 145 and it has first name as Rowena. So if you see hits here, so total number of hits is 1, so it is able to provide you only one result. So if you would see here, the match is the query which we are using here. Query first name as Rowena. Likewise, I have one more example which I can show you. So this is same working on the bank data. So I'll just quickly add it here. So now what this query is doing, this query is actually a range query, which is getting me the documents for the range of balance between 44,999 and somewhere around 90 lakhs. So GTE means greater than equal to, LTE means less than equal to. So let's see. So if you would see here, I'm getting 94 search results, out of which they are giving me the balance as this. All right. So likewise, there are several queries which you can execute. Let's jump to the slide again. What are index APIs? Index APIs, they are responsible for managing all the aspect of indexes like settings, aliases, mapping, index templates, and all those stuff. So these are some of the keywords which we use in the API. We can create the index. So these operations which we can do, we can delete the index, we can get the index, we can open or close the index, we can get the list of the index templates or aliases or different stuff. Let's talk about the cluster API. Cluster API, it is used for getting the information over the cluster and its node and making changes in them. So as I said, this is a distributed environment where we have a lot of nodes, and this Elasticsearch environment can be a multi-node deployment as well. So in this case, the cluster API gives us the information with respect to the cluster. So if in case I can show you in my deployment. cluster health. Why is it not taking? Anyways. So if you would see here, I have ran this cluster, send the communication to the cluster API, and I got this response with respect to my cluster, where I have a cluster name as Elasticsearch, so I didn't made any changes in the cluster name. And the number of nodes I'm using here is 1. So I have a cluster of only one node. So by default, Elasticsearch will be installed in the cluster mode only. So irrespective of whether you are using a standalone installation or a distributed installation, there will always be a one cluster and that will be created by default, and your nodes will be a part of that cluster. So it will give you some more information like shards, active shards, number of data nodes, and all those stuff. So not even cluster health, you have cluster state, cluster stats, pending cluster tasks, cluster reroutes, node stats, node hot threads. These are some of the commands which you can execute to get more information. So let's find out how Query DSL is used to define queries. So Query DSL is nothing but it's a kind of a domain specific language which we generally use in our environment to perform operations. So whatever queries we write it in this DSL. So DSL is nothing but it's a domain specific language. So Elasticsearch provide a full query DSL based on JSON to define queries. Query DSL is an AST of queries consisting of two type of clauses. So there are two type of clauses, majorly the leaf query clause and the compound query clause. So if I talk about the leaf query clause, it look for a particular value in a particular field. So for example, so whatever with the help of this, if in case we are finding a particular value, like suppose I give you an example like match, term, range, or queries. So that is what leaf query do. If I talk about the compound query clause, it combines the leaf query clause and other query clause to form a compound queries. So it is more or less like a leaf or a branch structure where leaf will only be working on a particular value, whereas branch will be a combination of leaf structure as well as the multiple leaf structure, I should say. So let's find out how documents are mapped in the Elasticsearch. So mapping is basically a process of defining how a document and the field that it contains are stored and indexed. So there are different mapping types as well as different field types like meta field as well as the field or property types. So if I talk about the field type, so there can be multiple field type like geodata or specific data type, or if it is a complex query, so you'll have complex data type or even a core data type. So these are just the categories of different field data types. So these are some of the mapping parameters which we have, like which we can use in our queries, like boost, analyzer, copy to, geo hash, if in case you're working on geo hash, for formatting. So if in case you want to make the output presentable. Likewise, there are some more like include, in all, index options, fields, norms, null values, etc. So let's find out how the data is configured. So the analysis plays a very important role with respect to how the data is actually stored. So during the search operation, when a query is processed, the content in the index is analyzed by a analysis module. So analysis module contains analyzer, tokenizer, token filter, and character field. So the process of converting a text into a token and terms which are added to an inverted index for search is called analysis, and it is done by the help of an analyzer. So analyzer can be inbuilt or it can be like custom analyzer. So analyzer converts the fields into tokens, and with the help of token filters we can further perform the operations. So I'll give you an example of this. So there can be different analyzer on based of which we can perform the operation. Where is it? Okay. So what I'll do, I'll write the simple query, analyze, ANALYZE. I don't know why it is not taking the completion. Maybe some browser issue. So I'll type the analyzer as white space. So I'll use the white space analyzer. TESPACE, right? This should be the correct spelling. And I'll add a text to be work upon, which will be like, suppose Elasticsearch is the heart of Elastic Stack. Actually, my browser is misbehaving, so let me reload the stuff. So what this analyzer will do? This will take out the white space from this particular sentence. So wherever there will be a white space, it will divide this particular sentence into 1, 2, 3, 4, 5, 6, 7. 7 different tokens. So this is what the analyzer do. So the content in any index, so I mean there can be different kind of analyzers. There can be stop analyzer. Yeah, so what do stop analyzer do? Stop analyzer is basically used for stopping the particular, so if in case you have a certain keywords which are being used again and again, like the, a, r, so these are some of the keywords which are used again and again. So what do stop analyzer do? It will remove all those keywords and it will present the rest of the tokens, rest of the terms in the form of tokens. So this is what the analyzer do. So let's find out modules and the different type of modules in Elasticsearch. So different type of modules, there are basically two kind of modules. One is the static as well as the dynamic. So Elasticsearch is composed of number of modules which are mainly responsible for its functionality. Two different type of settings which we have, like static as well as the dynamic. So with respect to the static settings, they need to be configured in the YML file, the configuration file, before starting the Elasticsearch. So certain modules which are there by default, those are basically dynamic modules. But if in case certain modules which you have to mention in the configuration file, that means the elasticsearch.yml file, so those are categorized as static modules. So these are the module types which we have. We have made a pyramid so you can quickly have a look. So that's all for today for this webinar session. Please don't forget to share or like the YouTube channel, this particular video. And thank you very much for today's webinar session, for joining in. Bye-bye.
I hope you enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries and we will reply to them at the earliest. Do look out for more videos in our playlist and subscribe to our Edureka channel to learn more. Happy learning!